Let's talk about some additional notation we're going to be using in this section. I went ahead and drew two vectors on our graph paper. The first one is vector I, which is going to be a vector that runs along our x-axis and ends at the point 1, 0. Vector J is going to be the vertical vector running along the y-axis, ending at the point 0, 1. Let's say we're talking about vector V, and it has components here of A and B. We could also use this notation to represent our vector. Let's see what happens. Remember that this vector 1, 0 is equivalent to vector I, and this vector 0, 1 is equivalent to vector J. So we can write new notation for vector V. Instead of seeing the vector V in this notation, vector AB, you might also see it written in this format, AI plus BJ. They're equivalent vectors. Let's take a look at a few examples. Let's start with vector V as the vector 2, 3. We could also write this in the form 2i plus 3j. We also have vector W, which is the vector 3, negative 4. Again, you might see it in this notation instead, 3i minus 4j. Let's calculate V plus W. Remember that when we're adding vectors together, we're going to be adding the x components of our vectors, and we're going to be adding the y components of our vectors. When we add the x components together, we're going to add 2 plus 3 to give us 5. When we add the y components together, we have 3 plus a negative 4, and that gives us negative 1. So our vector v plus w is the vector 5, negative 1. Let's take a look at what happens when we subtract two vectors. This time we're going to be doing v minus w. When we subtract these, we're going to be subtracting the x components, in this case 2 minus 3, to give us a negative 1. And we're going to subtract the y components, 3 minus a negative 4, which would give us a positive 7. The vector v minus w would be equivalent to the vector negative 1, 7. Let's calculate 3v. We're going to multiply each component by 3. 3 times my x component is going to give me a positive 6, and 3 times my y component will give me a positive 9. Let's do two more. For part D, we're going to calculate 2v minus 3w. Let's set this one up. Here we have 2 times vector v minus 3 times vector w. Remember that in this case we're going to multiply each component by the 2, and on this one we're going to multiply each component by 3. We're going to be subtracting these two vectors, 4, 6 minus the vector 9, negative 12. Keep in mind when we subtract, we're going to subtract the x components and then subtract the y components. This will give us the vector negative 5, 18. And for the last part, let's calculate the magnitude of v. When we're calculating magnitude, notice you have vertical lines on either side of the letter v. This represents magnitude, or the length of v. Since it's similar to us working with a right triangle, we're going to be squaring the a components and b component, adding them together, and then taking the square root, the equivalent of Pythagorean theorem. When we plug in each piece, 2 squared plus 3 squared is going to give us 4 plus 9. That's going to give us a total of 13 underneath that radical sign. So the magnitude of v is equal to radical 13